Hello students, welcome to physics class. Today we discuss the product of two vectors. There are two ways to multiply two vectors. One way produce a scalar quantity and we call as scalar product. In another way which produce a new vector which is known as vector product of two vectors. Let us discuss what you mean by the scalar product of two vectors. Here, the scalar product means the scalar product or dot product of two vectors A and B is defined as the product of the magnitude of A and B and cosine of angle between them. The scalar product is also known as dot product. The scalar product of two vectors is defined like this way. The scalar or dot product of two vectors A and B is defined as the product of the magnitude of A and B and the cosine of angle theta between them. For example, here we have two vectors A and B. The angle between these two vectors is theta. And the scalar product, this is also known as dot product, between A and B is A vector A, read it as dot, vector A dot vector B is equal to the scalar magnitude of A into the scalar magnitude of B into cos of angle between these two, A and B, that is cos theta. Magnitude of A into magnitude of B into cos theta. That is the dot product of A and B. A dot B is equal to AB cos theta. So the angle between these two vectors, that is cos of angle between these two vectors, can be written as cos theta is equal to A dot B divided by AB. A and B are the magnitude of A and B, that is cos theta is equal to A dot B divided by AB. What theta is the angle between A and B. And we know that in this product A dot B, A and B are actually scalar quantity because they are the magnitude of vector A and B. So they are scalar. A and B are scalar. Cos theta is also a scalar quantity. Since A, B and cos theta are scalar, A dot B is a scalar quantity. A dot B is a scalar quantity. But you know that A and B are vector quantity, vector A and vector B, but their product or the multiplication, the result we are getting a scalar quantity. That's why we calling this multiplication as the scalar product or dot product. If you are multiplying these two vector, we getting a scalar quantity. The result is a scalar quantity. That's why it's a scalar product of vector. Let us see some physical example for scalar product. For example, work. Work is the scalar product or dot product of force and displacement vector. Work is equal to F dot S. The work is a scalar product of force and displacement vector. So work is a scalar quantity. Now another example, the power is equal to F dot V. The power is the dot product between the force acting on a body and its instantaneous velocity. The P is equal to F dot V. Power is a scalar quantity, And phi, the magnetic flux, is equal to intensity of magnetic field B dot A, area vector. So flux is a scalar quantity. Since B and A are vector quantity, but their product is a scalar quantity. So these are the some of the physical example for scalar product of two vectors. We are multiplying two vectors, but the resultant is a scalar quantity. Dot product or scalar product of vector. Now see some properties of scalar product. Some important properties of scalar product. The A dot B is equal to B dot A. That is vector A dot vector B is equal to what? Vector B dot vector A. So we can say scalar product is commutative. Scalar product is commutative. That is A dot B equal to B dot A. Then it is distributive over addition. The scalar product is distributive over addition. That is vector A dot vector B plus C. Vector B plus C in bracket. So we can write A dot B plus A dot C. That is the scalar product is distributive over addition. The third property, if A and B are perpendicular to each other, if two vector, that is A and B are perpendicular, then we can write A dot B equal to AB cos of angle between them. Since the vector are perpendicular, we write as 90. AB cos 90. You know cos 90 is equal to 0. So A dot B equal to 0. If two vectors are perpendicular, A dot B equal to 0. If you want to check whether two vectors are perpendicular, just take the A dot B. If you are getting A dot B equal to 0, we can say that the two vectors are perpendicular to each other. Then if A and B are parallel, if two vectors A and B are parallel, then what is A dot B? A dot B equal to AB cos 0. Angle between two parallel vector is 0. So AB cos 0. AB cos 0 is 1. A into B. Then, if A and B are anti-parallel, if two vectors are anti-parallel, anti-parallel means this is vector A and this is vector B, vector A and B are anti-parallel. Then what is A dot B? A dot B is equal to AB cos 180. Angle between these two vector is 180 degree. Angle between these two vector is 180 degree. So what is A dot B is equal to AB cos 180, that is equal to minus AB. Cos 180 is minus 1. That's why it become minus AB. Okay. Then what is A dot A? A dot A. A dot A is equal to magnitude of A into magnitude of A. That's A into A. Cos of angle between them. Angle between them is 0. So cos 0 is 1. A square. What is A dot A? A dot A is equal to A square. Then I dot I. What is I? Is a unit vector along x-axis. So what is I dot I? I dot I is equal to the magnitude of I. What is magnitude of I? It's 1. Because you know it is a unit vector along x-axis. Into magnitude of I. That is 1. 1 into cos of angle between them. Cos of angle between I is 0. That is cos 0. So I dot I is equal to 1. Similarly, j dot j and k dot k is equal to 1. What is j and k? J and k are unit vector along y and z axis respectively. J dot j equal to 1 and k dot k is equal to 1. But you are taking I dot j. I is a unit vector along x axis and j is a unit vector along y axis. So I dot j is equal to 1 into 1. The magnitude of I is 1, magnitude of j is 1, angle between I and j is 90. Angle between I and j is 90. So cos 90 comes to 0. So if you're taking similarly, if you're taking I dot j, I dot k, j dot k, all comes to 0. So I dot j equal to j dot k is equal to k dot I equal to 0. That are the sum of the properties of scalar product. Now see how to take the scalar product in terms of rectangular components. For that, two vectors A and B are given in form of rectangular component. That's A equal to AXI plus AYJ plus AZK. AXI is the x component, AYJ y component, AZK is the z component of vector A. Similarly, vector B is equal to Bxi plus Byj plus Bzk. Bxi is the x component, Byj y component and Bzk is the z component. So vector A and B are given in the form of rectangular component. Let us find how to take the dot product between these two vectors. For that, A dot B is equal to AXI plus AYJ plus AZK dot BXI plus BYJ plus BZK. So, first AXI dot AXI dot the second vector, that is bxi plus byj plus bzk, plus the second term ayj dot bxi plus byj plus bzk. Third term azk dot bxi plus byj plus bzk. But you know that the dot product is distributive over addition. So you're using that property, that is ax into bx I dot I. The second term ax into by I dot j. Third term ax into bz I dot k plus ay into bx j dot I, ay into by j dot j, ay into bz j dot k. Okay, the next term az into bx k dot I, az into by k dot j, and az into bz k dot k. Now we remove the bracket. Now a dot b is equal to ax into bx. What is I dot I? We know that I dot I is equal to 1. This term I dot I is equal to 1. Ax into by into I dot j. But you know I dot j equal to 0. When you discuss the property, we know that I dot j equal to 0. That's equal to 0. Second term comes to 0. Third term ax into bz I dot k. But I dot k is equal to 0. Now ay bx j dot I. What is j dot I? That's equal to 0. Ay into by j dot j. But you know j dot j equal to 1. That's why this term is also there. Ay into by. Ay into bz j dot k comes to 0. Az bx k dot I, that terms comes to 0. Az by k dot j, that also comes to 0. But az bz k dot k is there. K dot k is equal to 1. So the third term az bz into 1. So we're getting only these terms, this term, that's ax into bx, then ay into by, az into bz. All other terms to 0. So what is a dot b? The result a dot b is equal to ax into bx plus ay into by plus az into bz. If you want to find the dot product in terms of rectangular component, just to find what is ax into bx plus ay into by plus az into bz. That is the dot product of two vectors. A dot b is equal to ax into bx plus ay into by plus az into bz. That is the dot product of a and b, a dot b. That's all today. Thank you.